Hi, everybody. My name is Alexander, as you can see here. So I'm the CTO of the Arenadata. I will talk a little bit later about our company. So today I will talk about how we can use the Apache Ignite as an MPP accelerator. And here's the agenda for today. First of all, as I said before, I will talk about us, what we're doing, all about our platform. Second topic, it's all about the data warehousing and why the data warehouse currently needs the in-memory technologies. I will cover different real-time cases in telco industry because I spent a couple of years working in Pivotal and especially in telco area. And I will explain how we can integrate Apache Ignite together with MPP. And also I will show you the example how we can manage it using our platform and open source platform as well. So first of all, about us, we're the startup. We're founded in 2015. We're based in Moscow in Russia, but currently we start working in Eastern Europe as well, in South Europe. So we are contributors of the following projects. It's Apache PXF, Apache BigTop, and the Greenplum. And we are the members of Open Data Platform Initiative since our foundation, since 2015. So, and I will talk later about this initiative as well. Here is the example, and here is the screenshot from the ODPi side of the compliant platform. So the idea behind of this initiative is to build the common runtime specification for Hadoop distribution, because today I will talk a little bit about the Hadoop because this is the first product which were released. And as you can see here, we do the same thing as the Hortonworks, the IBM, Pivotal, Altiscale. And so here is why. So the first product which were released in 2016, it was the Hadoop distribution. And you can see here the logo of ODPi compliant. That means this distribution has a similar thing like the HDP or beacon site, so it's still working together with the SaaS platform and other ODPi runtime specification compliant platforms and solutions. But after we released the Hadoop, we start thinking about expanding our product portfolio because without the MPP platform or without the in-memory data grid platform, it's difficult to doing some projects in industries like the manufacturing or telco. And we released the product called Arenadata DB. It's MPP shared nothing platform. Today I will explain and we'll discuss about this more deeper. This product based on open source project called the Greenplum. It's one of the most popular MPP database in the world. Of course, in comparison with such platform like the Teradata or Vertica. And we released it in 2017. And the last product, which currently in development, which not released yet, but it's in GA, it's called Arenadata Grid. It's based on Apache Ignite. It's very similar with Apache Ignite, the open source version. But currently we are developing the platform, I mean the deployment and configuration tool, which allows you to deploy the Apache Ignite using the graphical user interface. Without any XML reconfiguration, so you just put some properties into user interface and then the cluster will deploy it on the selected hosts. It can be the bare metal configuration, it can be virtualization, it can be public cloud. So currently we're developing different different interfaces in communication tools with different hosts and providers. For example, currently you can deploy this product on top of the Google Cloud Platform or the bare metal, as I said before. And it's called the Arenadata Cluster Manager. So it's based also on open source projects like the Ansible. And also we adding some monitoring features. So you can use the Grafana and Graphite to collect the metrics for Apache Ignite because Apache Ignite provides very rich interfaces and description of Gmax metrics. So we just putting this all together inside a single point. It's called Arenadata Cluster Manager. But during the development, we start thinking how we can manage the data transferring between those different layers, because it's very difficult, especially when you're storing the hundreds of terabytes of data in Hadoop layer or MPP layer, how you can manage to transfer this data across the clusters, because it's usually the dedicated clusters, separated clusters. And we found a solution in the platform extension framework. Originally, this technology was developed for Pivotal Hawk project. Currently, it's Apache Hawk project. And this technology allows you to use the native clients to communicate with different platforms. And today, I will talk a lot about this technology, because for us and for our customer, currently is a key technology, which allows us to transfer the data, as I said before. And one more thing, which currently also in development, it's called the Arenadata Streaming. It's very similar with the Hortonworks data flow project. So it's consisted of the Apache Kafka, Apache NiFi, and we added also the graphical user interface for Kafka Manager. It's called the Kafka Manager, which allows you to control the topics and brokers to rebalance the cluster using the single point and the graphical user interface. So together it's called Arenadata Enterprise Data Platform, and it's absolutely open sourced. So, and we trying to pull and push all our changes into upstream projects. And so you can download all these products, available products, of course, which currently released from the store.arenadata.io. So don't be afraid, currently it's on Russian, but we currently trying to translate it to English. But you can use the Google Translate as well, if you don't mind. Okay. As you can see, we currently have 18 people as the key committers for different projects. And a lot of the internal and external repos, like more than 14. And of course, without the big partners, it's almost impossible to doing business today. And we have a great portfolio of partners here. And I will say the great thing. Thanks for the Grid Gain for such opportunity to participate in today's event. And actually, we have the partnership with Grid Gain, which allows us to participating in developing our products and the products around the Apache Ignite. Also, we have the partnership with IBM. So currently, we building our platform for the power architectures and power systems. And also, we have the partnership with Informatica, so we can currently proposing the solution together with Informatica. And for example, we have the OEM products based on Informatica Big Data Management and data quality called Arenadata ETL and Arenadata DQ. So we can proposing for customer the common solution based on open source and enterprise-ready software. So, and why the in-memory, why the data warehouse needs the in-memory data grids? So the answer is very simple. As I heard today and yesterday, many of the speakers talk about the new generation of business cases and use cases, and that's really true, because the world has changed and there is a lot of new business cases appears. For example, it's a very interesting example on the right bottom corner is the gen sequencing. For example, in 2001, in the beginning of 2000s, the cost of sequencing one genome cost more than $100 million. And today, and especially, of course, in 2014, today, it costs less than $1,000. And it can take hours in comparison of months or years before. And I see many examples in manufacturing, because today we have a lot of customers from manufacturing who want to implement new business cases, for example, the predictive maintenance and etc., to control the manufacturing and to see everything about their company and processes. And I participated in a number of projects in automotive industry. And you know, there is a lot of example. For example, the German manufacturing companies trying to implement the connector car architecture, which using the data from the different vehicles and collect the telemetry information and analyze it. And for me, today it's really important to have all information about myself, about my money, about my accounts instantly. So I just want to pay by my Apple Pay. For me, it's really strange if I cannot do it, and I need to put my banking card somewhere, and et cetera, et cetera. And I really like this diagram. It's called data value chain. It describes the dependency of data value and the data age. And as you can see here, the most valuable data for a company located on the left side, it's in milliseconds and seconds. It's something happening right now with customer, with your manufacturing, and etc. And on the right side, the aggregated data, the data which you are collecting the many years, the 10 and more years. And the problem is that today many of companies and many platforms which are building during the last 5 or 10 years inside the company located in the middle. So you can manage only and can process only the data from weeks till a couple of years maybe, not more. Because it's really difficult to process the data, the huge volume of data if you have the old school technologies. And that's why it's happening, because the many companies starting the implementation of modern data platform evolutionary. For example, it's the basic conception and idea of data warehouse, and many companies start implementing the data warehouse 10 or more years ago. And it's very simple. So you just have the structured data sources like the CRM, ERP systems, and etc. It's structured data. And you have the very simple, the ETL or ELT process, which loads the data from the relational data sources into central silo called the data warehouse. And maybe you're trying to increase the quality of data and using the data quality technologies, or you're trying to just increase the speed of transferring the data using the change data capture, but it's not real time. So it's new real time maybe, so you're just trying to replicate the data from the structured data sources in some standby database, and after you trying to put this data in micro batches into data warehousing. And there was a lot of problem with the, as I said before, with the huge amount of data, for example, with the hundreds of terabytes or petabytes of data. And that's why the new conception called data lake, which originally presented by James Dixon a couple of years ago. And as you can see here, there is a new types of elements in architecture which allows you to load and ingest the data from another type of data sources like the social networks. Basically, it can be unstructured or quasi-structured data. And usually for this, many companies start using the Hadoop. And that's why we start our journey from Hadoop, because in Russia, especially, the spirit appears in 2015, 2016, and it was really successful period for us to implement the Hadoop inside the company. And as you can see here, it may solve only the problem with the huge amount of data. But what about what we should do with the in-memory data? And that's why the Lambda architecture appears. So the idea originally presented by Nathan Martz, and you can read it about in Hadoop Definition Guide and in Lambda architecture book. It's really cool and interesting book for everyone. So there is another stage appears. It's called the speed layer on the top, and it consists of usually consistent the real-time engine or staging based in memory or data pipeline. I will talk today about this. And also they're using the queue for the transfer data between the managing the data and the data pipeline between the in-memory and the so-called the master dataset layer, which originally can be the same, the data warehouse or the data lake as well. And the last part of this architecture is called the storing layer. So usually it's some kind of the layer which allows you to querying the data from the speed layer and master dataset layer. So, but it seems that this whole architecture has transferred and transformed to Kappa sooner, because the previous architecture is very complex and it's very difficult to manage and to configure and to monitor and maintain a lot of different technologies together. And it's called Kappa architecture, and as you can see here, it's using only the in-memory solution. It's simplification of the Lambda architecture, but many of companies who currently start implementing the IoT platforms, many of the manufacturing companies start using it. And maybe you heard the name of the fog computing, the term of fog computing, and that's it. So you just can deploy the in-memory solution on the edge, near the edge, and process the data in real time. So, and here is some examples of the real cases in telco. The first example and first business case which I will wish to review is the customer retention. As you can see here, it's the customer from UK, because there is the map of the United Kingdom. And the problem is about the customer retention. When we start working with this customer, to be honest, it was in Pivotal when I was the Pivotal employee. But they start using the similar technology which I talked today about. So the problem was in customer retention, as I said before. And when we start analyzing the data, we found a very interesting thing, because the customer in that period ingesting and using the different data sources, including the unstructured data sources, using the Hadoop, start using the Hadoop. But we found that they're not using the information from the base stations and the base logs and from switches. So when we start using it, we found a very interesting correlation between the calls breakdowns, connection breakdowns, and dependency of the customer location. Because for me and for other customers, the telco customers, it's really important to have the good quality of connection at home and at work. So it's pretty normal if I'm driving and I'm lost connection. It's okay, maybe. But when I'm trying to call from home and from work, it's really ridiculous for me if connection breaks down. And we start using the geo-positioning information, geo information about the customer's location. We found the big clusters of the customers, and we found start using the information from the base station, from log files, when the connection breakdowns, because this information not loaded into billing system, so you don't have info in data about the call breakdowns. So you just see some the very strange things about some problems with the communications. So we found the clusters, and then these customers start working to improve the quality of network around these clusters, and then they start monitoring in real time when the connection breakdowns appears. They start sending appropriate information to customer with some message. Oh, sorry, John, so we found and we encountered some problems in this area, and we start working on it. And actually, this approach gives a very significant result for customer retention. That's the first example. And the second example is the Geo Marketing. So it's very simple because many of the telco companies around the world have a partnership with different third-party companies like the cafeterias and etc. And for example, they have very rich information about the customer behavior, because the telco industry have a very good quality of data inside the data warehouses. And for example, they knew all about which coffee you prefer because you're trying to search something in your browser and mobile phone and etc. And they have a partnership, for example, with some cafeteria. And when John walking near the old street, for example, and the telco provider know about it, they can send appropriate information to John. Hey, John, there is the Starbucks coffee around the corner. You can visit it. You have discount 10%, and etc. So, and it works. And how we can manage it today and how we do it today. So here is an example of the static constraint model. So when you have the data store or data lake, and you just ingesting the data using the ETL or code-based system, and then you process it. It's, this approach is very difficult because, as you can see here, it's code-based. Usually, for ingesting the real-time data, the many companies start using the Flume agents, for example, and it requires the very huge coding background for developers, and you have the code-based ETL. And it's very difficult to ingest the real-time information, real-time information. Yes, we can use the Flink, for example, or we can use the Flume and load the data, but it's really difficult to process data in this huge data lake store. And how we can migrate to proactive self-improving machine learning system? It should look like this, because you need to so-called data stream pipeline. This approach allows you to process data in flow. And of course, you need to remember real-time engine for the process the real-time data. And you need some kind of machine learning system which allows you to integrate inside the real-time data platform and your data lake as well. Because as I showed you before in this diagram, it's really necessary to have the very huge amount of the aggregated data to build and develop accurate behavior models, for example. And then you should migrate this model in real-time engine. And many of companies using so-called technology called sandboxes approaches. For example, when you have the huge data lake and you have the different the expert system or machine learning system like the Spark or R servers, and usually you have the separate dedicated groups of data scientists who just offloading the data from the data lake into a dedicated silo and try to analyze this data. And there is another problem with the sandboxes because you just got a different heterogeneous data sources inside your company, and it's really difficult to reuse the results of each groups of data science together. So that's why we proposing so-called data streaming reference architecture. As you can see here, it's very simple. So you should have a very few elements of this platform. The first one is a data lake. The second one is a real-time engine. And of course, a data stream pipeline. And as you can, if you remember, I show you our portfolio, and that's why our portfolio consists of the following parts. And of course, here is the example of our platform. So we're using the Arenadata Hadoop, Grid, DB, and streaming. But you can use another open source software or different enterprise-grade products. For example, you can use the Teradata, you can use the Grid Gain as well, and you can use the Apache Kafka or other products for streaming. And of course, you need the rich machine learning and machine learning systems platforms. Here is some example of the MADlib and Python, because the Python is the most popular thing for data science today. Actually, we start working in data science world since our beginning in 2015, and we saw many examples of successful using the Python, because currently the data science can use more than 1,000 different packages of data science and machine learning and deep learning algorithms inside the Python. And for us, it's key technologies as well. How we can integrate the Apache Ignite with Arenadata DB. Here is the architecture of Arenadata Grid. As I said before, it's very similar to Apache Ignite. So it's the picture from Apache Ignite. I hope you know a lot about this technology. So idea is very simple. We have the dedicated clusters. Usually it's the circle topology. And we can load the data into cache and using the key value for storage. And when we choosing the technology for us, which technology we can use for in-memory data grids, we choose the Ignite because we're considering other projects like Apache Geode and others. But for us, it was really important to have the really good SQL interface, because Apache Ignite uses the H2 for SQL. And we start using it mostly as the data grid. And here is typical use cases how we using the Apache Ignite. In this example, it's called Arenadata Grid. So the first case, which we are currently considering, it's the MPP Accelerator. So we can use the Ignite as an MPP Accelerator. The second case, as you know, the Apache Ignite can work as a secondary Hadoop file system. It's called Ignite FS. It's pretty good, but we now currently start thinking about using the Ozone because the Hadoop 3.2 will provide such opportunity and such technology to use the object store in HDFS. And the last use case, it's called fast data streaming cache. So we're using the Apache Kafka or other streaming or MQ technologies to aggregate the real-time data inside in-memory cluster. And then we can throwing this data down using different interfaces. For example, we can just upload the data to MPP platform or the Hadoop platform as well. And a few words about the Arenadata DB or the Greenplum. So it's a very simple architecture. It's MPP shared nothing, originally based on Postgres. So it's Postgres syntax for using many of DB from Postgres world can use the Greenplum, very transparent. And as you can see here, the topology is very similar like the Hadoop. We have the master service and master host, and we have the segment host. And that allows us to scale out, to build a scale out architecture. We can increase the performance and storage layer by increasing the number of the segment servers. And usually we're using the 10 gigabit bandwidth interconnect to transfer the data between the segments, because it's necessary to shuffle the data between the data nodes, the segment hosts. And we are the core developers. So as I said before, for us, it's a core technology. For example, last thing we added, it was the ZSTD compression. Originally, it was developed and designed by Facebook. And we actually was quite surprised by the performance and possibility of the ZSTD compression. For example, it's more than 4 times faster and more than 4 times as well efficient in comparison with MADlib compression. And also we fixed many of minor and major bugs inside the Greenplum. And we actually using the Greenplum as a core technology for our data lake or our data warehouse architecture. Greenplum uses the parallel query optimizer. So it's really similar like in Teradata. So they're using the different methods for shuffling the data, broadcasting, and splitting the data across the cluster. And of course, one of the greatest features of the Greenplum This technology allows to use in-database processing using the machine learning algorithms. For example, we are supporting the MADlib. It's open source library of machine learning algorithms originally developed in Berkeley. And so we are using this library in different projects. And as you can see here, there is not so much machine learning algorithms, but usually there is common algorithms which very, very popular in data science world. And the biggest feature of this library and this technology is that allows you to run it in parallel, and you can use the SQL syntax to build a linear regression. For example, you just can write the select linear regression from blah, 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 and then the Greenplum transfer and interpret this syntax into the functions inside the Greenplum. And the secondary greatest feature for us and for our customers, so-called the polymorphic table storage. And that allows you to split the huge table into different partitions. And for each partition, you can define different parameters and configuration of storage level. For example, you can store the historical data on slow hard disk drives and the hot data on SSD. And actually, this is originally the first iteration of polymorphic table storage, and I will show you a little bit later how we a little bit changed the feature of this idea. And also, you can define the different the formats for storing. You can store the data in row or in column, and you can define a different compression algorithms. For example, for column-oriented partition, you can define the earlier compression, and currently ZSTD for row. And I will show you a little bit later how we can improve the performance and the possibility of this approach. But the third part of the greatest features is called the platform extension framework. As I talked before about this possibility. So there is the original conception of this framework. As you can see here, it's a Java class. It's a Java server which running inside the Greenplum, usually inside the Greenplum cluster on the Greenplum host, which allows you to communicate with different third-party systems like the Hadoop using the native clients. And here is an example how we can integrate the Greenplum with the Hadoop cluster. For example, we can just reading the data and writing the data to Hive, HBase, or HDFS simple files like the CSV. And originally, it was very, very stupid technology because they're just offloading the data from the Hadoop inside the Greenplum cluster and then process the data inside the Greenplum. It was really difficult because you just need to understand. So because there is a huge amount of data inside the Hadoop cluster, and you need to offload this data inside the Greenplum, then process it, and then return result. It works, but it was very difficult to handle, as I said before, the huge amount of data. And currently, this technology supported the following lists of the profiles. The first is, as I said before, the HDFS files. The second is Ignite. So today, this profile provides the integration with Apache Ignite. And that's our development and feature, and we contributing this feature to upstream project. Today, it should be available from the open source project Greenplum. And as you can see here, it's very simple. So we just creating the external table with standard types of the columns. And we just defining the location where is the external table exists. And here is an example, the profile Ignite. So we're creating the Ignite cache called test, and we just define the buffer size 10,000 bytes. That's very simple. And also the similar approach for creating the Hive table, average, base, and etc. The profile is actually the bundle of usually four Java classes. It's called fragmenter, accessor, resolver, and analyzer, whatever. Okay, if it will be interesting. So fragmenter just return the source data fragments. The accessor is given the list of available fragments from data source. The resolver records according to given schema or technique, and the analyzer just collecting the data from and statistic from the source system, because it's necessary for the optimizer to have information about what is the destination system, what is the external system, which table there has, and etc. And how it works. For example, here is the very simple table. As you can see here, there is the free partition. The first partition, it's by date. It's more than January 2018. The second partition is partition between the January 2018 and January 2015, and last partition less than January 2015. So when we doing this, it's very simple idea behind. So you just choosing the dependency of cost of storing your data on different hosts and the dependency of latency. So as you can see here, if we're storing the data in the Greenplum or Arenadata DB, the latency, when you're querying the data, the latency, it's pretty average in seconds, and it costs some middle price of in comparison with different external tables. If you're storing the data in Hadoop, the latency if you're querying the data, it's 10 of seconds and costs less, of course, in comparison with the Greenplum. And if you're storing the data in memory, it costs a little bit more, but the latency when you're querying the data in milliseconds. And today I will show you the example of how it works in real time, in real life. And actually, the greatest feature which we added to the PXF and the polymorphic table storage option, it's a pushdown. Because when you querying the data where the date is more than January 2018, so the first thing that Greenplum allows you to eliminate the unnecessary partition with unnecessary data. So this technology just querying the data which have the appropriate data and appropriate information about this query. And the second feature, when you're querying, for example, the complex filter, for example, where the date is more than something and user ID less than something. So this filter criteria currently transferring to external system and querying all necessary data, for example, where the user ID less than 400, and then this system returns to you or to Greenplum only information with such criteria. And there is the different filters working if the table located inside the Greenplum or the table located outside the Greenplum, for example, in Hive, HBase, or Ignite. And the PXF works in the similar way in such systems. So, and the good news that our commit is merged, and currently, as I said before, available in upstream in master branch, as you can see here in Greenplum. So that allows you to build your own the PXF protocol and the Greenplum platform if you need it, and querying the data from the in-memory data grids as well. Because the Ignite connector is available as well from the original master branch. And also we added the support of in-memory, pushdown feature for JDBC connection. So you can define the JDBC external table, and you can query the data from any other JDBC supported platforms, any in-memory solutions with such support. Okay. I just show you the example. Here is the schema of the test bench. I prepared this example especially for this event. So as you can see here, we've got 2 nodes clusters for Hadoop, for Greenplum, and for Ignite as well. 1 master nodes for Hadoop layer and the Greenplum layer. And the green arrows, it's the PXF interaction way. As you can see here, the all segments between the Greenplum and Ignite and Greenplum and Hadoop communications all with each other. And the bold line called internal affinity functions. It means that each cluster coordinates the data shuffling inside. So it's necessary to have this information inside the Greenplum to understand which data we have and how it's distributed across the cluster. And here is an example of creating the real table in Greenplum. As you can see here, we've got the 4 partitions. And the third partition currently defined as the column-oriented partition using the compressed type zlib with level 5. And other compression by default created as the heap partition in Greenplum. So at this point, it's the Greenplum internal table. And we just loaded the data, the simple data, inside the Greenplum table and querying it. It's a really simple table, so here it is, it works. So yes, we're using the Apache Zeppelin for querying and creating the data because the Zeppelin allows us and for our customers to connect and interact with different elements of our platform on their ecosystem from single point. And the second example, second table, sorry, we're creating the external table inside the Greenplum, the writable external table, which creates the in-memory cache in Apache Ignite with the following configuration, as I showed you before, with the appropriate name of the buffer, cache, the size of buffer, and we added the feature of creating the partitioning. So as you can see here, this partitioning it's by ID in range 10, so it's 10 partitions. And we just inserting the data from the Greenplum to Ignite, Apache Ignite, and querying the data. And here is, sorry. Okay. And here is the result. Yes, we just currently ingest the data from Greenplum to Ignite and querying the data from the Ignite to Greenplum, and it works. And the third example, it's just we're creating the Hive table, the pretty similar steps for Hive, and the loaded data from the Greenplum to Hive as well. And as you can see here, we've got the result. And here is a little bit magic, because it is necessary currently to do these steps to have the polymorphic external partitions in Greenplum. As you can see here, we just exchanging the existing partition of Greenplum with external table in memory and in Hive. And what we've got, if we querying the Postgres catalog, sorry, here is the simple query of selecting the data about, selecting the metadata, sorry, about the table from the Postgres system catalog. As you can see here, we have the table with 4 partitions. The first partition in range from 0 till 20. It's external, it's X storage. It's external in memory partition. The second partition is the heap partition in Greenplum, storing in heap memory in Greenplum cluster. The third partition is columnar partition in Greenplum, storing in disk storage. And the last one partition, it's external partition in Hive, in range of ID 16 till 18. And when we're querying the data, it's a very simple query. Sorry, once again. Whoa. It's not working. Can we please change this? Oh, thank you. So it's a very simple query, and there is an execution plan of this query. When we select all records from this heterogeneous table with the criteria where ID is less than 14, so the Greenplum just querying the 2 partitions. The first partition, it's one more, please. The Greenplum heap partition, it's partition 2. It takes an average 38 milliseconds to end for scanning because they're very short amount, the few amount of data, the few data inside. And one more, please. The second partition in our it's the first partition, it's Ignite partition, it takes 0.1 millisecond to scan till end. But Greenplum eliminates all other partitions from this query, and we just querying the all necessary data for us with the following performance. That's it. Thank you very much.